Hi guys, good evening. How are you all? So I see some people out there. Yeah, Manish, good evening. Sundareshwar, good evening. Kashyap, good evening. Okay, yeah, session started. I'm there. So just one update, guys. So Paridhi won't be here today. Okay, so I'll be here for I'll work as both moderator and your trainer for today's session. So kindly um, excuse us for that. Okay, yeah, Adityan, good evening. So I'll just wait for some few more people to join in, and then we would start the session. So yeah, we say good evening. Hi. Okay. So yeah. So I'll be dealing with all your queries and all. I'll be going to your chat and all. Obviously, there would be our teammate, our teammate would be in the background, would be sharing the links and all. But yeah, so on the screen we'll just see me for today, guys. I hope Paridhi would be back on Monday and she would again join us in the session. Yeah, Shubh. Good evening. Yeah, Abhishek. Good evening. Rohit. Yeah, hi. How are you all, guys? So nice weekend, right? So Saturday was yeah, we are having a session, just a small session we'll have today, and I hope you have already enjoyed the Saturday morning. Okay, so the same Jill and all, we would start this session. Okay, we'll just have a fun day today. Okay, we'll not be very serious today. This is a Sunday, so we are all in a happy mood in the weekend mood. So guess what? I'll not take more than 1 hour today. So we'll end the session at 7. Okay, so just to go with the flow of the weekend vibe. Okay. Yeah, Rohit, good evening. So, what was the Nikhil? Yeah, good evening. Okay. What was the last thing we discussed, guys? We discussed searching, right? We discussed linear search. We discussed binary search. So, searching we had done. Before that, we had also compared. We had seen a comparison between function and method of Python. Okay. And before that, we had done this delete operation from beginning. So, we are done till searching. Today, I'm picking up sorting, guys. We'll discuss few sorting techniques or few sorting algorithm. So those are like bubble sort, selection shot, insertion shot. These three basically sorting technique I'm picking for this session. Yes, there are more sorting techniques like quick, merge, heap, shell. So those would be taken care in the full stack course, guys. Okay, so Nitesh, yeah, hi. So one doubt about exam. What is the time and date for exam? Okay, Nitesh. Anyway, you would find all the details regarding that over mail. Okay. First of all, after the session, you would find the eligibility. You'll get the eligibility list would be released. According to that, the next day, so one day would be gap. Then after that, there would be examination date. To be very specific, just give me a moment. I'll say your exam day. Okay. Okay. So it should be on 4th, guys. But I think there would be. Okay, I'm not very sure right now, but I think there would be delay of 1 day or something. But it's scheduled to be on 4th. Okay, timing, the test window would be like 11 to 2, but you can give any 2 hours between that. Again, you'll get all the detail finally over mail. Okay, don't worry about that. Also, you can visit the community, guys. All the details are already there. Okay, so I don't have right now handy with me those information, so I just have to get through it and again say you. But let's not waste our time on that. Anyway, you'll get all the detail over mail. Also, you can like visit our community for all those details. Okay. Yeah, Mukesh. Good evening. So, yeah, guys. So let's start this session. But as we do, before starting this session, I want to all to spam the chat box, spam the comment box with your favorite emojis or any emojis you want, guys. Just put it there, and then we will get into our session. Yeah, I'm just waiting, guys. So just put your emojis, favorite emojis over the comment box, and then we would be good to start our session. Okay. Mukesh is asking, okay, okay, that's very specific question. I think I'm not sure whether to answer that. Yeah, I'm in Bhubaneswar. This place is Patia. Okay. So yeah, put your emojis, guys. Mohan has initiated putting emojis. So kudos to Mohan. Yeah. What about others, guys? Just put your emojis. Put emojis, and we would be starting our session for today, which is sorting. We'll discuss bubble sort, insertion shot, and selection shot. Okay, now I see some emojis out there, some emoticons out there. Um, Good going, guys. Great. Yeah, thank you for putting up this emojis and making this comment box colorful. So, with that note, let's get into our discussion. That is bubble sort. We'll start with bubble sort. Let me share a screen with you all. First of all, just give me a moment and I'll share it. Meanwhile, you can find the attendance link in the description box, guys, and if you want to put the attendance right now, you can put it, or if you want to put attendance after the session or towards the end of the session, that is also fine, you can put it. Okay. Also, as we said in the previous session, you can visit community, guys, and put your queries over there, so that other friends of yours who are also attending the session with you might help you in your queries or assignment or some doubt and all. Okay. Or one of our team member would be there to assist you. So I hope the screen is visible to you all and I'm loud and clear to you all. So, okay, can anyone just give me a confirmation about that? Is it visible? Am I properly audible? I will move forward with the discussion. Okay. So I'm asking today you guys because we know Parit is not there, so she is not there to confirm me. So I need confirmation from you all. Is it all fine? So anytime any issue happens, you're not able to see something, you're not able to hear something, just spam the comment box then and there. I'm continuously seeing the comment box actually, so I'll get to know and I will act accordingly. So yeah, I see some confirmation. Thank you for your confirmation, guys. So yeah, now we can start with discussion. So we'll talk, as I said, about sorting algorithms. So these three sorting algorithms we'll discuss: bubble sort, selection sort, and insertion sort. Okay. So I'll start with bubble sort. So basically, you can see these few pointers, guys. It is easy to implement. Bubble sort is very easy to implement, very easy to understand also. What we do here, we compare adjacent elements. Okay, we compare adjacent elements and we check if current element is greater than next element, then we swap. When I am saying we want to sort the array, okay, when I'm saying I want to sort the array, I mean to say I am to arrange the element in ascending order. Okay, when I say reverse sort the array, then I mean to say arrange the element in descending order. So sort generally means arranging the element in ascending order. Okay, if you want to arrange in descending order, then you have to be very specific. You have to mention very specifically reverse sort or something. Okay, so here we compare adjacent element and check if current element is greater than the next element. Obviously left side element should not be greater than the right element if you are sorting it. So in that case, you swap them. So we continuously do this thing and finally we'll have the resultant array as a sorted array. Okay. So for that, I'll go to whiteboard, guys. So we'll be going back to a good old friend, that is whiteboard. So let's meet him and greet him. Okay, so I hope you are all seeing this whiteboard. So, hi whiteboard. Let's start scribbling around here. Let's try to understand how this bubble sort works and all. So let's take an array. So I'll take the same array, guys. Like I have used 9, maybe. Okay, yeah, 9, 6, 5 0 8 2. This is the array given to us. So in bubble sort, what we do, let's put the indices 0 1 2 3 4 and 5. So we compare 5 and 6, sorry, 9 and 6 first. 9 and 6, so 9 is greater than 6, so we need to swap them. So 9 would be here. Then we compare 9 and 5. 9 is greater than 5, so we need to swap them. 5 would come here, 9 would come here. Then 9 and 0 would be compared. 9 is greater than 0, so again you swap. So 0 would come here, 9 would go there. Then 9 and 8 would be compared. 9 is again greater than 8, so again this would be swapped. So 8 would come here, 9 would go there. Then again 9 and 2 would be compared. So yeah, 9 is still greater than 2, so we have to swap 2 and 9. Okay, we say that now first iteration is over after this point. First iteration or first pass is over after this point. So that's how bubble sort works, right? Works. So next, in the next iteration, we'll compare again this two thing, 6 and 5. So again you see 6 is greater than 5, so we swap them, swap it, 5 and 6. Then 6 and 0 would be compared. 6 is greater than 0, swap it again. So 0 will come here, 6 will come here. Again swap 6, again compare 6 and 8. 6 is not greater than 8, so 8 would be there in the place, no swapping will take place. Then 8 and 2 would be checked, compared. 8 is greater than 2, so swapping would happen here, occur. Then 8 and 9 would be compared. So 8 is less than 9, so nothing would be done. So 9 would be here. We say that this is the array content, or this is the content of the array after second pass. The array is not at all sorted, okay, not fully sorted yet, but we have completed two passes or two iterations over here. Okay. Rohit, there are different techniques through which we can sort. So we are learning here different techniques so that we can have a comparison which one to go with finally. Okay. Like bubble sort, it has it might have some other some benefit compared to other. And then selection shot might have some benefit over other logic, other algorithm. Insertion shot might have some benefit over other sorting technique. Similarly, quick sort, okay, bubbles, merge sort, heap sort, they might have some other one or other benefit over other. But the thing is, when we know all the sorting technique, then we can choose which one to go with finally. Okay, if I ask you which is the most preferred sorting technique, then it is quick sort. Okay, but again, if you compare the time complexity and all, so that says a different thing. Okay, that says a different thing. So what we'll discuss that in detail in our full stack course. Let's not get into that right now. Let's complete this bubble sort thing first. Okay, I'll discuss few things about this bubble sort. So we have here completed two passes or two iterations over here, 5 0 6 2 8 9. Next, so I have this 5 0 6 5 0 6 2 8 9. Okay, then I'll compare again. This 5 and 0 would be compared. Okay, again 5 and 0 would be compared. 5 is greater than 0, so 0 and 5 would be swapped. Then 5 and 6 would be compared. No swapping would be done because 5 is less than 6. Then 6 and 2 would be compared. 6 is greater than 2, so swapping will occur. So 2 would come here, 6 will come here. 6 and 8 would be compared. Nothing to be done. 6 is less than 8, not greater than 8. So 8 is there. Again 8 and 9 would be compared. 8 is less than 9, so nothing would be done. So this is what it is, like you are here after third pass. Okay, third pass. Till now the array is not sorted completely, but we are now at third pass. If you continue this step, finally you will get your sorted array, guys. Because see, when 0 and 5 would be compared, when 0 and 5 would be compared, nothing would be done. 0 and 5 would be still in the same place. But 5 and 2 when would be compared, 5 is greater than 2, so swapping will take place. Then 5 and 6 would be compared, no swapping. 6 and 8 would be compared, no swapping. 8 and 9 would be compared, no swapping. So you see here we have end up with a sorted array. Okay, fourth pass. after fourth pass, you can say. Okay. Anyway, so this is how we go for bubble sort. Okay, I see some question. I think it's already answered about the exam thing, so I'm not getting to that again. So see here. So this is bubble sort, guys. This is a technique which bubble sort follows. Let's now get into this Jupyter notebook and try to implement this logic. The same thing, whatever we have seen now, however we compared and they did this swapping and all. Let's implement it. So I'll quickly share Jupyter notebook with you. Okay. So where is that Jupyter notebook? Let me find it. Yeah. Okay, I got it. Is it visible, guys? I have shared a Jupyter notebook with you. Is it visible to you all? Just give me a confirmation. Yeah, we do only one swapping at a particular time, but in a particular pass, there are a lot of swapping might occur. At one time, at the same time, we are doing one swapping. But in the same pass or in the same iteration, many swapping may occur because we are continuously comparing adjacent elements, right? Okay. So here we'll take a list, an array, you can say. So int I or I in import dot split. Okay, so here we can just give some message, enter values, that's all. Right, so this is how we take an array of integers and we do sort it. So let's call this function bubble sort, which will actually sort the array. So we need to define the function bubble sort. So def bubble sort, bubble sort. Okay, so what to put here basically? Yeah, basically passes are loops. Yes, Vikas. Each iteration, I'm saying each iteration or each pass. So basically loop. Here we have a nested loop actually. We'll understand when we get into the algorithm here. Okay. So see here. For I in range 0, comma. Okay. I will go till I'll go till n minus 1. Okay, why I'm going till, see, when I'm putting here n minus 1, I'll go till n minus 2 actually. So 0 to n minus 2. How many passes, guys? 0 to n minus 2. How many passes? You can say? I'm starting from 0 and I'm going till n minus 1. So 0 to, if I'm writing here n minus 1, it will go till n minus 2. 0 to n minus 1, n minus 2. How many values? N minus 1 values. So the outer loop or passes, the number of passes would be n minus 1. In n minus 1 passes, the array would get sorted. For each pass, what I'm doing, I have to compare each adjacent element. So for that, I have to write one more loop. Actually, you can also write for yeah, that's fine. We can go for 0 to n minus 1. For j in range, let's keep it 0 to n minus 1, guys. So 0 to n minus 2, I value would run from 0. It will take value from 0 and it will go till n minus 2. Total 0 to n minus 2, that is n minus 1 time outer loop will run. That again means n minus 1 passes. So in n minus 1 passes, the entire array would be sorted. That is what we are saying here. Okay, so j loop will start from 0 and even this one I'm writing n minus 1. Why n minus 1? I want to go till n minus 2 so that I can compare current element and the next element. The comparison which we make here is between array of j and array of j plus 1. So current element would be compared with the next element. If array of j is greater than array of j plus 1, if in case you write here n, if you want to go till n minus 1, so maximum value of j would be n minus 1, right? N minus 1 is the index of last element. So when j is n minus 1, what is this comparison? It will compare AR of n minus 1 and AR of n. What is AR of n? There is no element at index n, guys. You are going beyond the range of the array index. So your array out of bound, you're going. So that's why I want to go till n minus 2, so that maximum value of j would be n minus 2. At that point, I can compare ARR of n minus 2 and ARR of n minus 1. Second last element and last element. So if this is the case, then we need to swap them, right? How can we swap them? It's very easy. Swapping in Python is very easy. So just write ARR of j comma ARR of j plus 1 equal to ARR of j plus 1 comma ARR of j. This is how you swap in Python. ARR of j comma ARR of j plus 1 equal to ARR of j plus 1 comma ARR of j. Okay, right? This is how we swap. Fine. So this swapping will take place, and finally, so see guys, this is in each iteration I'm comparing adjacent element and swapping them. Got it? Okay. Finally, in the next iteration again the same thing will be carried out. Okay, let's execute this. Let's execute it. Let's see what is the content of array over here. Is it sorted or not? So I'll just take some value 965082. Hit enter. Okay, it says name error. Name n is not defined. Okay, sorry guys. I was speaking it out, so I have just taken n here. You need to find n. What is n? N is nothing but length of the ARR. That's all. Okay, so 965082. Okay, you see, we have got our array sorted 025689. Understood this, guys? What we have done here in bubble sort, the logic, the algorithm. Is it clear to you all? Or any issue on this? Any doubt on this, guys? Clear? Okay, I hope it's clear to you all. I want to go back to this whiteboard to discuss something here regarding bubble sort. Okay, we can improve this. We can do some improvisation here. Okay, this loop is not very efficient. I'll talk about that. Okay. Yeah. Okay. Fine. I'm explaining it once again. See, guys. This is the number of passes. I think we'll get back to the whiteboard. I'll write something there. You guys, I guess you would understand there. Again, when I come back to this Jupyter notebook, I guess that the picture would be clear. So what I'll do is I'll go back to this whiteboard. Okay, I'll again come back to Jupyter, and then you would find it very comfortable. Okay, see guys here. I hope you are seeing the whiteboard along with me. Okay, Rohit, I'm just putting it here. See, I'm saying if you clearly look out over here, after first iteration, after first pass, your 9 has been put in the rightmost place. Okay, so we say that 9 is at its correct position actually. Okay, after second pass or second iteration, we say 8 has been put at correct position. Okay, see, after each pass the next maximum element is taken towards right. Okay, after first pass the greatest element is pushed toward the rightmost position. After second pass the second highest element was pushed to the right side. Okay, second right position. After third pass the next bigger element, next great element, next largest element was put to the right side. After the next pass, after fourth pass, next big element is put. Okay, but you are not sure about this one. This is visible to us that 0 is less than 2, but how come machine would know? It has to compare, right? Okay, already 4 element has been sorted, but it is not very sure about the rest 2 elements. So it will run one more pass. It will run one more pass. It will compare 0 and 2. It will see that okay, 0 is less than 2, so no swapping would be done. So it would be as it is. Again, if it compares 2 and 5, nothing would be done. If it compares 5 and 6, nothing would be done. And if it compares 6 and 8, nothing would be done. Okay, and 8, if it compares 8 and 9, nothing would be done. So finally your array is this, which is actually sorted. So in how many passes we sorted? Actually fifth pass. After fifth pass we sorted the array. What is the total number of element, guys? 6. In how many passes we sorted the array? Fifth pass. So total n minus 1 passes are there, or there are total n minus 1 iterations that we need to sort this array using bubble sort. Okay, that is why I have used the loop there from 0 to n minus 1. This is a range function, right? When it is range function, I would pick up value from 0 till n minus 2. So 0 to n minus 2, how many values? 1 to n minus 2, n minus 2 value plus 0, that is one more value. So total n minus 1 values. So that means the outer loop I loop is running for n minus 1 times. That is nothing but the number of passes. Understood now why I have written the outer loop as 0 to n minus 1? Because I need n minus 1 passes to sort the entire array. Understood, guys? This part. I'll then go to the second loop, the inner loop, basically nested loop. What is n minus 1? N minus 1, n is the length of the array. N is the length of the array, number of element in the array. N minus 1. N minus 1, I'm taking n minus, in n minus 1 passes, the array is getting sorted. That's all. Okay, I hope Rohit is like now it is clear. Mohan and Roshan, is it clear to you all? Just confirm, guys. Is it clear to you all? Roshan and Mohan. Okay, great. So next, in the inner loop, what I'm doing, I'm just comparing. I see what we did in the first pass. We compared 9 and 6. Then we compared, so 9 and 6 we compared, we swapped them, 6, 9. Then 9 and 5 was compared, we swapped them. Then this 9 and 0 was compared, we swapped them. Then 9 and 8 was compared, we swapped them. Okay, then this 9 and 2 was compared, we swapped them. That is what I did. See, last comparison is between n minus 1 in n minus 2 index and n minus 1 index, because n minus 1 is the index of last element. I cannot go beyond that. That is why j loop I started from 0 and I went till n minus 2. Okay, the same loop, range of 0 comma n minus 1, range of 0 comma n minus 1. If I write, I'll start from 0, maximum j would be n minus 2, so that when the final value of j would be n minus 2, and I can compare a of n minus 2 and a of n minus 1. I should not go beyond n minus 1, right? Because I'm comparing a of j and a of j plus 1, the next element. That's why the inner loop is the same, 0 to n minus 1. Okay, so that's how the loops are designed. 0 to n minus 0 comma n minus 1, range of 0 comma n minus 1 I have written over there, right? Okay, coming on the same note, guys, again the same thing has been put by who had put? Anupam has put a point over there. Yes, I'll go to the same note here. We want to improvise the code. If you mark here clearly, after first pass, which I've already told you, the largest element is on the right side. Okay, the largest element is on the right side, and okay, just a moment, guys. Fine. So after first pass, the largest element is on the right side. Then after second pass, 2 elements are sorted. Last 2 elements are sorted. After third pass, last 3 elements are sorted. after fourth pass last 4 elements are sorted, and after fifth pass last five elements are sorted. We are just left out with one element. We know we don't have to do anything else, so we say it is sorted. So after each pass, we know now that one more element has been sorted. It is pushed to the right side. So after first pass, do we really need to compare 8 and 9? No, right? We don't have to compare because we know that 9 has been sorted already. It is the greatest element which is present at the last position. So we don't have to compare 8 and 9. Just stop here. Don't compare 8 and 9. Again, after second pass, we know that 8 and 9 are sorted. They are at the correct position. So then, do we need to compare 6 and 8? Okay, do we need to compare 6 and 8? No, right? We don't have to compare 6 and 8. Why should we compare? Right. So we'll stop at here. We don't compare 6 and 8. 8 and 9 are already sorted, so no need to compare with 8 and 9. So leave them. Now, after third pass, we know that 6, 8, and 9 are sorted. So no need to compare with 6, 8, and 9. Just stop there. Stop before it. Okay, right? So basically, we are comparing. We are doing an extra comparison here, which is not required at all. So to get rid of those extra comparison, what I will do is we will modify the loop condition, guys, of the inner loop, because I don't have to compare with the rest of the element on the right side, the rightmost elements. I'll not compare. After first iteration, I don't have to compare with the last element. After second iteration, I don't have to compare with last two element. After third iteration, I don't have to compare with last three element, and so on. So what I can do is here, if I write here minus I, they would start from 0. It will go till n minus 1 minus I. First time when I is 0, j will go till n minus, like the range, the last value of range is n minus 1. Okay, so all the values would be compared. In the next iteration, I would be 1. So it is basically n minus 1 minus 1. So you are excluding the last element. You are not comparing with the last element. So now we will not compare with 9. It is not required. Okay, so in the next iteration, I value would be 2. So you will not compare with the last two element. Then I value would be 3. So you will not compare with the last three element. So we have improvised this code, guys. So we now have a bit like more efficient code compared to the before. Compared to the earlier code, we now have an efficient version of the code. Let's try it out whether it is still giving us the sorted array or not. Let's try it out. Yes, we are still getting the sorted array. Understood, guys? This one. Why I put here minus I to make it more efficient, because we don't have to do those extra comparison. We don't have to compare with those right elements which are present on the rightmost side. Those elements we don't have to compare anymore. After each iteration, we don't have to compare like consecutive elements at the end. I hope it's clear to you all, guys. Understood? Fine. So we'll not stop here itself, guys. We'll not stop here. We'll improvise this code more. Okay, let's make it more efficient. How we would make more efficient? So for that, I would again go back to whiteboard, and or maybe here itself I would say, guys, let's see it. See, here I have 965082. Okay, maybe I'll have array as 05052 689. Let's say this is an array. This is the array given, guys. So after first iteration, what 0 and 5 would be compared? Nothing to do. 5 and 2 would be compared. Yes, there would be a swap. So 0, 2, then 5 and 6 would be compared. Nothing would be done. Fine. 6 and 8 would be compared. Nothing would be done. So 8 and 9 would be compared. Nothing would be done. So this is the result after first iteration. Okay. Anyway, as per this code, we'll go for the second iteration. Okay, again this 0 2 would be compared, nothing would be done. 2 5 would be compared, nothing would be done. 5 6 would be compared, nothing would be done. 6 and 8 would be compared, nothing would be done. Okay, right? 8 and 9 comparison will not be done because now we are in the second iteration. So again we are getting the same array, why we are actually doing this? We already have the array sorted, but as per the logic here, this comparison will continue for n-1 passes. Okay, unnecessary comparison we are doing, guys, right? Unnecessary comparison we are doing. So we want to get rid of this unnecessary comparison. So let's modify the code a bit through which we can actually avoid this unnecessary comparison. If at a point of time we are getting the array as sorted, then we must not continue the comparison. We'll stop there. We should stop there. So how to do it? See here. How can we do it? So what I'll do is, for each iteration, I'll take a flag variable kind of this. Okay, let's just swap. Initially, swap value is 0, right? And whenever I'll swap something, if swapping is occurring, we are swapping something, then I'll make that swap as 1 to denote that yes, swapping has been done. Got it, guys? After the inner loop, after this j loop, what I'll do is I'll check what is the swap value is. If it is still 0, then that means no swapping has taken place. When we swap, guys, when we find the elements are not in order, if any element is like if current element is like greater than the next element, then we swap. If no swapping has been done, that means the elements are already in order. That means the elements are already sorted. There is no need of swapping anymore. So if swap value is still 0, then you get to know that okay, the elements are in actually order, ascending order. No swapping needed, no more comparison needed. We just can come out of the loop. Okay? Come out of the loop, from the outer loops, like the no more passes will carry on, no more iteration will take place. So you're done with the thing. If swap is not 0, then again you'll move on to the next iteration. Swap would be initially again 0, initialized to 0. Again this will take place. This will go on. So I've just added this thing, guys, this part and this part, which is making us avoid the extra comparison over here. Let's try it out. Is this still working for us? 965082. Hit enter. Yes, it is giving us a sorted array. But this is way more efficient than the previous code, right? Okay. So just imagine you going to an interview. Your maybe other guy, one of your friend has gone to the interview. Maybe some other person has gone to interview, and the interviewer has asked to write the bubble sort logic. You have written this code, and your friend has written that other person has written the previous version. Obviously, clearly it is visible over here. You will get the preference because you have written an efficient version of the bubble sort algorithm, right? I hope you understood, and I hope this is interesting to you all, guys. Okay, so just say yes or no, guys. Did you follow? Did you understand this? Yes or no? Put your responses in the comment. Say yes if you understood. Say no if you did not. I'm just waiting for your responses, guys. Just spam the comment box with your answers. Just say yes or no if you understood. Say yes. If you didn't, say no. And I would look forward to it. I'll move accordingly. Okay, I'm still waiting for your responses, guys. Okay. So this is bubble sort. This is an enhanced version of bubble sort, guys. This is efficient version of bubble sort, I would say. I'll move on to the next thing, the selection shot. I see you are saying yes in the comment box. So that means you all understood what it is all about, what we have done here. This is bubble sort, right? Great then. Okay. Let's now talk about another sorting technique, that is selection shot. Okay. Yeah, Mohan. Okay, I'll just do it once more. See, Mohan, I have taken a flag variable, just some variable, just to denote either swapping has occurred or not. So initially swap would be, for each iteration, I'll start the swap value with 0. Okay. In the inner loop, at any point of time, if I am swapping anything, then I'll assign swap as 1. I'll assign 1 to swap, that to denote that yes, swapping has occurred. So after coming out of this inner loop, I'm checking for the previous iteration, for the current iteration, any swapping has been done or not. If no swapping has been done, then the only conclusion is the elements are already in order. That is why no swapping was done. That means no need of any more comparison. So just come out of the loop, break the loop. So this outer loop would be terminated. You will be out of the function. So your bubble sort out of the loop, and then finally you will be out of the bubble sort function. So your array is sorted already. No need to carry out again those comparisons. Clear, Mohan? Now? Yeah, Anil, hello. So Mohan, I'm just waiting for response. I hope you understood this. Okay, coming to the next one, selection shot, guys. So let's see selection shot. What we did in bubble sort. In bubble sort, we picked like in each iteration, the largest element was bubbled out to the end, to the rightmost position. In selection shot, the trick is different. The way of sorting is different. What we will do there is we would pick up the smallest element and we'll put on the left side. So in bubble sort, the elements are arranged from right to left, the largest element, next largest, next largest, next largest, so on. But in selection shot, we'll sort it from left. The sorting would happen from left to right. The minimum element, next minimum, next minimum, next minimum. So sort the elements would be arranged from left to right direction. Okay. Let me just clear it out. Let's talk about selection shot. Selection shot, I'll explain the logic, guys. You would implement it. Selection shot. What we do in selection shot? I'll take the same array 965082. Okay, right. What I'll do is, guys, I'll not draw the array over here. Also, I'll not write over here. I need space because I want to write the logic here itself, and you need to implement that by your own. So selection shot, array is 965082. So this is the array 0, 1, 2, 3, 4, and 5. Yeah. So in selection shot, what we'll do, guys, we'll pick the minimum element. We'll find the minimum element. What is the minimum element here? Minimum element now is 0. So we'll take that 0 and we'll swap with the first element. Okay, so we'll get 0, 6, 5, 9, 8, 2. Fine. So we say that yes, the first element is sorted, the minimum element. Then next, we'll find the second minimum element, which is the second minimum element. Second minimum element is 2. So then we'll swap 2 and the second element. Okay, so we'll get 0, 2, 5, 9, 8, and 6. Now we say now the array content after second pass array content is this. We say 0 and 2 are sorted already. 0 and 2 are sorted. Okay, minimum, next minimum. Then we'll find again the next minimum. What is the next minimum element here? 5. Next minimum is 5. So 5 would be swapped with the same 5. Same thing, nothing would be done. Yeah, at the same position. So we'll get 0, 2, 5, 9, 8, 6. But we say that okay, first 3 elements are now sorted after third pass. So same thing will continue. Next minimum would be found. Next minimum is 6. So 6 and 9 would be swapped. Okay. After that, the next minimum would be found and would be swapped accordingly. So this is how the selection shot works, guys. So how do we do this here? It's very simple actually. Let's see this code. So for I equal to 0, I less than I'm writing a C version of code. We can easily convert that into Python code. I'll again say that how to do. I equal to 0, I less than n minus 1, I plus plus. Why less than n minus 1? Why it is not less than n? Because I don't want to go till n minus 1. I want to go till n minus 2, guys. Why is that? I'll just say now. Just wait for a moment, you'll get to know. Position is a variable which is supposed to hold the index of the current minimum element. Always position will hold the index of current minimum element. So if we are storing I in position, that means we are assuming that the first element now is the minimum element. Okay, so we are assuming 9 is the minimum element. We are assuming. Then we'll do the comparison with all other elements. Okay, so we'll do here for j equal to I, not I plus 1, j less than n, j plus plus. Okay, see, now I am going till n minus 1, j equal to I plus 1. See, I have taken 9 as the minimum. I have assumed that okay, 9 is minimum, current minimum. Then I'll compare with all other element, guys. If we find any element which is less than 9, then we'll make the index of that element stored in POS, because position POS is supposed to hold index of the current minimum. So I'll compare here. If a of position is greater than, or let me write in this way, if current element a of j, if any a of j is less than a of position, current minimum. When I write a of position, that means it is the current minimum element, guys. If current element a of j is less than current minimum a of position, then what we have to do? We have to change the position as j, because now a of j is minimum element. So we need to store index of the minimum element in position. Position is supposed to hold index of current minimum. Okay, so what we did here, so we have assumed that okay, this is I. Okay, this is I is 9, I is not 9, I is 0, a of I is 9. Okay, j would start from here. So I'll compare a of j and a of position. Again, initially position is also here. So 6 is less than 9. Yes, 6 is less than 9. So position would be changed. Position would be now here. Then j would be incremented. J is now here. 5 and a of position would be compared. 5 and 6. 5 is 5 less than 6. If a of j less than 6, yes, 5 is less than 6. So position would be changed. Now position would be here. Like 1 and 2. Position would be now 2. Then j would be incremented. Now j is here. A of j and a of position will be compared. Is 0 less than 5? Yes, 0 is less than 5. So actually position should be here, which is index 3. Again j would be incremented. So again it would be compared whether a of j and a of position is like which one is less, a of j or a of position. A of j is 8, a of position is 0. So a of j is not less than a of position, so nothing to be done. Only this j will get incremented. Again it will be compared. 2 and 0 will be compared. 2 is not less than 0, so nothing to be done. Position is after the completion of this loop, first iteration, position is holding 3, guys, index of 0. That means 0 is the minimum element. So after completion of this inner loop, you need to swap a of I and a of position, the current minimum and the leftmost element. You have to swap them. Like here we did 9 and 0 would be swapped. That is what we did here. Again, next time I value would start. So now, okay, let me just write down the array here. Next time, the array content is now 0, 6, 5, 9, 8, and 2. So this is done. This part is done. Now I is here. So j will start from here. We'll compare with all these elements. We'll try to find the next minimum element. So position will also start from here initially. We'll compare a of j and 6. 5 is 5 less than 6? Yes. So now position would be here. J would be here. Is 9 less than 5? No, nothing to be done. So j would be incremented. Is 8 less than 5? No, nothing to be done. So j would be incremented. Is 2 less than 5? Yes, 2 is less than 5. So position would be here basically. Index position would be index of 2. That is nothing but 5. Okay. So finally, you would swap a of this 2 and 6. A of I. This is I, right? This is I. So a of I and a of position would be swapped after the after getting out of the inner loop. So this is how we do this selection shot, guys. I hope you can easily convert this into your Python code. This would be for I in range 0 comma n minus 1, right? And this loop would be for j in range I plus 1 comma n. That's it. Okay, you know how to the condition would be more or less similar. You just have to put this colon over here. remove the semicolon. If even if you write the semicolon, there is no issue at all. Okay, instead of calling a swap function, you can just write the statement a of I comma a of position equal to a of position comma a of I. It will just swap them. This is the selection short logic, guys. Okay, did you understand the algorithm of selection short, how it works, how it sorts the array? Okay, is it clear to you all, guys? Did you understand this, how it is working? Swap a of I and a of position here. Is it clear? I hope you understood this selection short. It's not very difficult. We are just assuming that okay, this is the minimum element. Then we'll compare. Then we are comparing with all other element. If we find any element which is less than the current minimum, then we are saying okay, this is the current minimum. Then we are again comparing with the rest of the element. Rest of the element we are comparing. If we find any more element, like any element which is still less than the current minimum, then we make that minimum. We take that element as minimum, and finally we swap the element with the left element. That's what we are doing here, guys, and we repeat this statement, repeat this process again and again, and finally we get the array as sorted. Okay, right, fine. What is the benefit of selection sort, guys, over bubble sort? Who can answer? We now know bubble sort and selection sort both. Who can say the benefit of selection sort? What is the advantage of selection sort over bubble sort? Time complexity wise, guys, bubble sort will take big of n square in worst case. Selection shot will also take big of n square in worst case. So what is the advantage over here? Advantage here for selection shot over bubble sort. Who can say? I'll just wait for your response. When we should prefer selection shot over bubble sort? What is the benefit? What is the advantage of selection shot over bubble sort? Okay, in bubble sort, in best case, we have seen there that it might happen if the array is almost sorted and all, so it will just have one iteration. After that, we would stop our iteration, right? See, guys, in selection shot, in each iteration, there is only one swapping we are doing, only one swap operation we are doing. But in bubble sort, in worst case, it might happen n minus one swapping. Okay, or just don't say the exact swapping, just say there will be more swapping, obviously. Okay, if in worst case there would be more swapping. In selection shot, always in each iteration there would be only one swapping. So if number of element are n, then there would be maximum n minus one swapping over here. Right? In bubble sort, there would be many many swapping. Okay, so swap operation is more in bubble sort compared to selection shot. In selection shot we do less swap operation. That's what you can say a benefit here in selection shot. Space complexity, this selection shot and bubble sort, it actually both are in place sorting technique, guys. In place means you are not taking an extra array. In the same array, you are doing changes. So space complexity is fine. It is same for both. Okay, constant time complexity you can say. Just this overhead, swapping overhead is less in selection shot. In bubble sort, swapping overhead is more. Okay, we cannot say space complexity is increasing just by one if we just add one more variable or something. No, if we take n number of let's say we take one array of size n for that purpose, then we say yes, space complexity is increasing. But if we're just taking one more variable, we should not say actually space complexity is more. Swapping over it is less in selection shot. Okay, so you take this, okay, and you try to implement this. Okay, I would move on to this insertion shot, guys. Insertion shot. Let's see that. So insertion shot is always like not always. Sorry, selection shot is also known as playing card sorting technique. So if you have seen anyone playing card, so you might have noticed that they pick a card and they find where to put it. Okay, so they pick a card and they check actually what is the correct position for this card to place, and they place once they find the correct position, they place that card there. Okay, similarly insertion shot works in a similar manner, guys. In insertion shot, we pick an element, we call that as key element, and we find its correct position. We find its correct position where to place. Once we find its correct position or perfect position, we place it there. Okay, so here comes into account something called perfect position or correct position. What do we mean by correct position or perfect position? See, when you place an element in a perfect position, then all the element to the left of it should be less than the element, and all the element towards right of it should be greater than the element, guys. Okay, got it? Raghav, Anupam, it's not, you cannot actually say position is created again and again for selection shot. Okay, we are just initializing again. So if you compare with the C version of code, we can declare it once, right? Outside the loop, we can declare it once. We are just reassign the value. We'll store different value in every iteration. That's all. So don't say that space complexity would be big of n there. Okay, coming to the insertion shot. So I'll take the same example 9, 6, 5, 0, 8, and 2. 0, 1, 2, 3, 4, 5. See, guys, I'll make you understand how insertion shot is working. Okay, as I said, I'll pick an element which I'll call it as key element. So I'll pick this element. Let's say I'll call it as J. Okay, I'll make this 6 as the key element. Okay, then what I'll do, I'll take this as I. Okay, I want to compare this 6, this key element, sorry guys, I want to compare this 6, this key element, with the element which are present on the left side. I want to make sure that on the left there should be no element which is greater than this key element, because that's what we discussed. We want to place this key element at its perfect position, so there should be no element on the left which is there should be no element on the left greater than this element. All the elements on the left should be less than the element. All the element on the right side should be greater than the key element. So we are now focused on the left side, guys. First of all, we'll compare the elements with the left side. Then we will go for the right side. Okay. Then we'll go for the right side element. Let's see here. So first, I will compare this key element and I. So let me just write the loop here for j in range, or should I write the C version of this and we can easily convert into Python version. Let's do that and we can easily convert into Python version. So j equal to 1, second element I'm starting, j less than n because I want to go till the last element. Okay, and I'm taking this key j, basically a of j, you can say a of j as the key element. Okay, I am starting from j minus 1, just the, yeah, I is here because I want to scan compare with all the element on the left side. If j is here, I will start from here. Yes, I would start from here and I will compare with all the element on the left side. Okay, so while I is greater than 0, I'll come to it, guys, don't worry, and a of I greater than the key. Till this condition is satisfied, I will shift the, okay, let's come to here. What is this condition? Let me first explain you. See, now key is 6, 9, a of I is 9, 9 is greater than 6. So what we should do, guys, we have to shift this 9 towards right, because 9 cannot be on the left side of 6. So take 9 towards right, then I minus minus. Why minus minus? Because I need to compare with all the element on the left side. But now when you do I minus minus, you are actually going out of the bound of the array. So you are now I is minus 1. I started from 0, but I is the minus 1. So that is not a valid index. So we'll stop here. Finally, you say you store this key element at here. We say that okay, 6 has been placed at its correct position. On the left of it, no element is greater than it. Obviously, it is placed as 0. Yeah, of course, but you can say yes, there is no element on the left which is greater than it. And on the right till j, on the right till j, all the elements are greater than it. Okay, after J, we don't know about them. We have not yet scanned them. We have not yet explored them. So we know only till J. So key element is placed here. 6 is placed on the left of it. There is no element greater than it. On the right of it till J, all the elements are greater than it. So we say that okay, 6 has been placed at perfect position or correct position. Okay, right? So this is what we'll do, guys. So if this thing will continue till I is greater than 0, or at I is greater than 0 and A of I is greater than key. Let me continue with the next loop, then you would understand what I'm doing over here. So first of all, let me just erase this. Okay, now J has been like J is 1. Okay, now J would be incremented, guys. Now J is 2. So I would start from here. Key element is now 5. A of J is key. So key is now 5. The same thing. We'll compare A of I and key. A of I is 9. 9 and 5. So what you will do? 9 is greater than 5. So swap, shift 9 towards right, because that is greater element. So we need to keep take them towards right. So swap, shift them towards right. So 9 is now here. I minus minus. Now I is here. Now A of I is 6, key is 5. 6 and 5, which is greater? A of I is greater. 6 is greater than 5. It cannot be on the left side. Move it, shift it towards right. So 6 would be shifted towards right. Fine. Now I minus minus again. When you do now I minus minus, you have gone out of the range. So this is where you should stop. That is where this condition comes into play, guys. I greater than 0. If I is not greater than 0, then you stop. And what you have to do now, you just have to put this key element at its correct position. And correct position is nothing but A of I plus 1. I is now here, which is minus 1. So A of I plus, in A of I plus 1, you store this 5. Okay, this is what we have to do here, guys. So we just write here, if I is greater than 0, while I greater than 0 and A of I is greater than key, you just shift A of I to A of I plus 1. Shift towards right, nothing else. Okay, A of I would be stored in A of I plus 1. Current element would be stored in the next location. So we have shifted the current element towards right. Finally, when we come out of the loop, what we need to do? We need to store the key element at the perfect position. And perfect position is nothing but okay, one thing I have missed out here, guys. After shifting, you just have to also like do this I minus minus. I should be shifted towards left. That step I have missed out to write. Finally, you will store this key element at A of I plus 1. That is what we discussed. This is the whole logic of insertion shot. Okay, you can easily convert this into Python, guys. Okay, let me do one or two more step, and I think then you will understand this algorithm what I am doing over here. So let me just get rid of this I here, and J would start from now this place. Okay, you know what to do now. I would start. Okay, I will start from here. I will start from here. Right, I is here now. Compare 9. So key is now 0. A of J is key. 9 greater than 0? Yes. So shift 9. Fine. I minus minus. 6 greater than 0? Yes. 6 is greater than 0. So shift key. So key would be here now. 6 would be, so not shift key, shift 6. 6 would be here now. I minus minus. 5 is greater than 0? Yes, 5 is greater than 0. So shift 5 towards right. So 5 would be shifted here. Fine. Then I minus minus. Now I is out of the range of the array, like out of bound of the array index. So we'll stop here. Finally, you store this 0 at I plus 1 position. So finally, this 0 would be stored at I plus 1 position. Right. Similarly, you'll continue the same thing, right? You'll do the same thing for J equal to 4 here. Okay, we'll scan with 9, 6. So, okay, let me do this one step. Okay, let me do this one step, and everything will fall in place. Why I have written that condition, that loop condition is that. Okay, see, now J is here. Now J is here, and I would start from here. So now key is 8. Of course, key is now 8. 9 greater than key? Yes, 9 is greater than key. So what I'll do? Shift 9. Fine. Done. I minus minus. 6 is greater than 8? No, 6 is not greater than 8. So this loop would terminate because this condition is not satisfied now. A of I is not greater than key, so we'll come out. Okay, so we'll stop here and we'll store this key element at a of I plus 1. I is here now because we compared 6 and 8. A of I plus 1 is this position here. So we would store that 8 here. We say that we have placed 8 at its correct position. To the left of it, no element is greater than 8. On the right of it, till j, all the element is greater than it. On the left, all the element are less than it. On the right, till j, all the element are greater than it. So likewise, you can work out for the next element, that is 2, the last element, and it would be sorted. So if you take j over here, guys, from 9 to 5, all will get shifted towards right. But when you compare with 0, the condition would be false. So we'll stop there. And finally, 2 would be stored over here. That is how this logic works. I hope you understood this insertion shot logic, guys. Is it clear? Just confirm me in the comment box, guys. This is insertion shot. Worst case, big of n square. Okay, but insertion shot is preferred when the array is almost sorted. When the array is almost sorted, then we go for actually insertion shot. It takes linear time complexity when array is almost sorted. So guys, yeah, okay, clear, guys. Just I need your confirmation. Just put in the comment box. Did you understand this? And we are good to wrap this session up. We are done with our today's topics. Sorting technique is what I need to discuss: bubble selection and insertion. So yeah, just give me a confirmation, guys. Did you follow this? Did you understand this? And then we can wrap it up, wrap this session up, and we can enjoy our weekend. Okay, so guys. So what do you say, guys? Did you follow this or any kind of issue you are facing? Just let me know. Okay, Nikhil says he understood. What about others? Is it clear, everyone? Okay. I think, yeah, everyone else has also understood. I got one or two response. Yeah, Amir also says understood. Yeah, so I think, yes, I hope then everyone over here has understood the thing, guys. So try to implement this, guys. I have already written the logic. You can easily convert this into Python thing, into range thing. I've already shown you how to do that in selection shot. You can easily do the same thing over here in insertion shot. So just convert this code into Python, and you are good to go. So for j in range 1 comma n, this is what you will write. And this while loop you will write while I greater than 0, and we write and a and d in Python, right? And we write a of I greater than key. Okay, put this, and everything else is same. That's what you have to do in Python. Fine then, guys. So as you all confirmed that you have understood this thing, so we are good to end this session with a note. But before we end, I just want you all to spam the comment box again. Let's end the session with a bang, and we'll again meet on Monday, guys, same time with some different topics. So we today discussed bubble sort, selection shot, and insertion shot sorting technique. In the next session, we'll talk about stacks and queues. Okay. Hey guys, so just let's end this session with some colorful comments over there in the comment box. Put out your emojis, put out your favorite emojis in the comment box, and then we would end this session. Okay, and I'm waiting for your responses, guys. Just put some emojis, and we can end this session. So I hope you enjoyed the session and understood whatever we discussed. I hope you understood, guys, and I have like reached out to one and every person who was like listening to the stream or watching the session. Okay, then, guys. So great. Then let's meet in the next session on Monday, same time. Ta-da! Bye and take care.